Alright, so what we're going to talk about now is the difference between formula and ionic equations. Okay, so as you may or may not know, formula equations are equations that include full chemical formulae for all substances involved. Okay, so full chemical formulae. So these are pretty standard. These are the sort of equations for chemical reactions that we're going to deal with the most. Okay, so they have full chemical formulae. Okay, now an ionic equation is slightly different. Okay, so basically when we want an ionic equation, the first thing we do is we write the formula equation, and then what we do is we translate from the formula equation to the ionic equation. Okay, so there are a few changes that we make when we do this process. Okay. So basically we look for these two types of substances when we're moving from a formula equation to an ionic equation. First, we look to see if there are any ionic substances in aqueous state in the formula equation. Okay, so we want to see if there's any ionic substances in the aqueous state. Okay, so for example, sodium chloride. So if we have sodium chloride solution, okay, in the formula equation, then we want to rewrite this. Okay, so now ionic equations are all about rewriting formulae to show the actual state of the substances involved. So we're rewriting formulae to show the actual state. Now, so in this example of sodium chloride aqueous, because it's sodium chloride solution, we know that the sodium ions and the chloride ions are in fact dissociated when they're in aqueous solution. So therefore we're going to rewrite this as a sodium ion in aqueous solution and the chloride ion in aqueous solution. Okay, so that's the first change we're going to make. When we write a formula equation, we look for ionic substances that are in the aqueous state, and we rewrite them we rewrite the full chemical formulae for the solution. We rewrite it as the individual ions in aqueous state again. So that's the first change that we are going to make. Okay. Now the second change, we next look for strong molecular acids or bases in the formula equation. Okay, so we're basically just looking for very strong acids that rather than being considered ionic compounds are in fact molecular compounds. Now an example of such a compound is hydrochloric acid. Okay, hydrochloric acid does look a little bit ionic, but it is in fact a molecular compound. Okay, and so this is very similar to basically what we did above just here. We're going to rewrite this as the hydrochloric actually is. So in aqueous solution, hydrochloric acid is in fact dissociates into a proton or a positive hydrogen ion. Now that's where this becomes interesting. See, the reason we're not considering this an ionic compound is because a proton or a H plus is not in fact an ion. However, if we consider it the same way we consider an ionic compound, we'll get the same result. Okay, so we're dissociating the proton and the chloride ion. So that's how we're going to write hydrochloric acid in an ionic equation, or any other strong molecular acid for that matter, or base. Now everything else we leave unchanged. Okay, so these are the two changes we basically have to make when we're going from a formula to an ionic equation. Okay, they're the two changes we have to make. We look for an ionic aqueous compound, and we rewrite it as its separate ions, and we look for any strong molecular acids or bases, and we rewrite them as we rewrite them as they are. So we rewrite hydrochloric acid as a proton and as a chloride ion, whereas everything else we leave unchanged. So we're basically just rewriting it as it is. All right, now one thing that can crop up, when we rewrite a formula equation as an ionic equation, is that we may have the same ion on both sides of the equation. Okay, so I'm going to sort of try and show you what I mean here. So if we have an equation where we have, we've got sodium chloride on one side, in aqueous state, and some other stuff going to, plus some other stuff going to sodium hydroxide aqueous plus some other stuff. Okay, now if we rewrite this as we've done up here, we're going to get a sodium ion in aqueous state plus a chloride ion in aqueous state plus the other stuff, and we're going to get it becoming a sodium ion and a hydroxide ion and some other stuff. So these are both aqueous plus some other stuff. Okay, so if we look at this closely, so we've written out the formula equation here. Okay, that's the formula equation. So now we've changed it to an ionic equation. Okay, but in doing so, what we actually have now is an equation where we have a sodium ion in aqueous state on the left-hand side and a sodium ion in aqueous state on the right-hand side. Okay, so here and here. And so now looking at this ionic equation, when we write this chemical reaction as an ionic equation, we realize that the sodium ion itself is actually undergoing no change. We have it in aqueous state on both the left-hand side of the equation and on the right-hand side of the equation. Okay, and so for that reason, we can cancel it out. Okay, because obviously including it in the equation is having no effect. It doesn't really show what's going on. Okay, the sodium ion is being completely unchanged. Okay, and so that's why we call the sodium ion a spectator ion. Okay, that's because it's unchanged in a reaction. It's in just like you go to the footy, you're not actually involved in the game, you just go and watch it. Sodium ion is basically going to the footy. All right, sodium ion is just hanging around while everything else reacts. Okay, but the sodium ion is not actually involved in what's going on. So that's why we call it a spectator ion. Okay, and so when we rewrite a formula equation as an ionic equation, and we get spectator ions, in this case sodium ions in aqueous solution, we just cancel them out and rewrite the equation without the spectator ions. Okay, so what we have as the correct ionic equation is Cl minus, or chloride, aqueous, plus some other stuff, the same other stuff as before, going to a hydroxide ion. Plus some other stuff. Okay, so it's basically we're just rewriting it, okay, and then we're checking to see if there are any spectator ions in the ionic equation. Then we cancel those out and rewrite what we have left, and that is the final and correct ionic equation. Okay, I'll do an example video so you can see how all this works.